So we have them listed again. This is the same kind of box I gave you on Friday where it has all of the inverse trig ratios. Remember the big thing I put on the board yesterday? Inverse trig ratios, what they help us do is they help us solve for angle measurements, or they just solve for angles. Where if we took the sine, cosine, or tangent, we would be able to find a side length. But when we use the inverse, sine, cosine, or tangent, we can find an angle measurement. Remembering that sine is opposite over hypotenuse, or so. Cosine is our adjacent over hypotenuse, our ca. And then tangent, our opposite over adjacent, our toa. So if I was trying to find like the inverse, trying to find the measurement of angle A, I would take the inverse tangent of the opposite side divided by the adjacent side. Again, this only works for right triangles, which is the focus for this unit. So I'm not going to try to trip you up or anything and give you something that's not a right triangle. This first example is just like what we saw on Friday when we went through the notes, where it's just kind of practicing with your calculator, making sure you know what buttons to hit. I'll write it out again. The first button you hit would be your second button, or some calculators, if it's like yours is a Casio, I think it's a shift button. Your second button, and then you either hit your sine, cosine, or tangent, depending on what button you're using, what you're trying to find. And then up on the screen, your calculator will give you, it'll say sine -1, and then a parentheses, or it'll give you cosine -1 and a parentheses, and then it'll give you a tangent -1 and then parentheses. And then you just have to input whatever number you're given, or whatever kind of fraction. So say this is x, this is y, and this is z. You just hit sine, second, sine, type in your number, you'll get out your angle measurement. So if we do these three examples quickly, if I'm trying to find the measurement of angle A, I know what the comparison or the ratio of the two side lengths are. I would say the measurement of angle A is equal to the inverse sine of, I take 3.29. So second, tangent, 3.29. Then we're rounding it to the nearest tenth. So this will be 73.1 degrees. I always try to be sure to say this degree because that reminds me that using inverse trig ratios gives me an angle measurement, not a side length. Then we want to find the measurement of angle B, and we're given the sine. So this 0.55 we get from taking the opposite side divided by the hypotenuse. And then if we use the inverse, we can find the angle measurement of B. So sine is 0.55. Use your calculator to go through and do that. Making sure it's already in degree mode, of course. Then we get 33.4 degrees. And then same thing for cosine of C. To find the angle measurement, the measurement of angle C, we have to use the inverse cosine, which is, for this case, 0.87. Rounding to the nearest tenth, or whatever it tells you to do. This one, 0.87. you get 29.5 degrees. So on the test, I'm not going to give you something like this, kind of like rudimentary and simple. This is just kind of our safety net to make sure that you can use the calculator. Depending on whatever calculator you use, just you can do all these steps. Example number 2 is where we're going to apply these things. On Friday, we said solving right triangles. That was kind of the title of our lesson, title of today's lesson. Solving for a right triangle just means finding all the side lengths and all the angle measurements. So in this triangle, we have to find 2 legs of our triangle, G and H, and we have to find the missing angle, which is G. So I'm going to go find the missing angle first. So I'm going to find the measurement of angle G. And since I'm already given 2 of my other angle measurements, 25 and 90, I can use my 180 theorem, that all my angles together have to add to 180. So angle G will be equal to 180 degrees minus 90 degrees, so that's angle J, minus angle H, which is 25 degrees. So, do some math. 180 minus 90 is 90. 90 minus 25 will be 65. So the measure of angle G is equal to 65 degrees. You wouldn't have necessarily had to do this step first. You could have used a trig ratio to find either one of these legs. It doesn't matter what order you're solving in. Sometimes you have to do one thing first, so everything you can get, kind of use another ratio, but it's kind of choose your own adventure when it comes to solving these. But now we have to find 2 legs of the triangle. So I'm just going to be using my sine, cosine, or tangent. And I get to choose which ones I want. I'm going to say if I use this angle 25 degrees, I can use the sine to find H, my opposite side. So this is kind of a new part of the problem. Sine of 25 degrees is equal to H over 13. That's my opposite side divided by my hypotenuse. And then we mentioned to solve for H, we have to get this 13 out of the denominator. So we have to multiply by 13 on both sides. Because what that math does, if we multiply by 13, it's like by multiplying by 13 over 1. These 2 13s simplify to 1, and we just have H over 1, which is just H. Then we'd have to multiply this side by 13 too. So our value of H is going to be equal to 13 times the sine of 25 degrees is equal to H. And it's a side length, so I know I'm not using my inverses. So 13 times sine of 25. Oops, syntax error, typed it in wrong. Sine 25. We get 5.5. We round it to the nearest tenth. So H is about 5.5. It doesn't give us units, so we don't have to do that part. Now we just have to find G is the one unknown we have left. Les is back there. You can check. Trying to find angle G now. Sorry, side length G. We have choices again. I could use 65, 25. Let's use, since we already used sine, let's do the cosine of 25 degrees. So our cosine of 25 degrees is equal to our adjacent side, which is G, over our hypotenuse, which is 13. So I'm taking G over 13. And then same thing, we have a 13 in our denominator, so you got to multiply both sides by 13. So 13 times sine of 25. Oop, I did this first hour too, cosine. I'm using cosine. 13 times cosine of 25 degrees is equal to G. And then again, just put that on your calculator, 25. So having a calculator on Friday for the test is going to be super important. So I have a limited amount. So if you have a friend that doesn't have math for 4th hour, or if brother or sister has a spare calculator, once mine are gone, they're gone. So this is 11 point, what did I say, 9. And that kind of makes sense because my longest side should be 13. G is my second longest side, so it should be less than 13. It is, it's 11.9. And H is my shortest side, 5.5. So kind of the dimensions are making sense to me. So you will have to do this on the test. So in this case, you would say, okay, well, these are my 3 things that I was solving for with some work shown. Last piece of this is just word problems. The word problems, they come up on the test a lot. They're not, I would say, difficult ones, but you just have to kind of think about what you're doing, especially if there's not a picture given. So my hint on a word problem, especially when you're dealing with right triangles, is always draw a picture. In this case, our picture is given. It says our school is building a stage. The stage will be 30 feet long from the front to the back with a total rise of 2 feet. And we want our angle of elevation to be 5 degrees or less. Then we're going to say, okay, well, is our stage within our desired range? So on your paper, it's a little hard to see, but this is where our right angle is. And this would angle X is our angle of elevation, so how high we're going up. So that's what we're trying to find. So we're looking at this angle X here. From this angle, I'm given my opposite side, and this 30 feet is our hypotenuse. So if I remember my SOHCAHTOA, I see, well, I'm given opposite and hypotenuse, so I'm looking for O and H, so I know I have to use sine. These two will not help me. And I have to solve for X. The sine of X is going to be equal to your opposite side, 2, divided by your hypotenuse, so 2 over 30. And we're trying to solve for an angle measurement. So we have to use inverse trig functions. So the measure of angle X will be equal to the inverse sine of 2 divided by 30. Most calculators, if you just put in 2 divided by 30, it'll work out. So 2 division by 30, just hit enter. If you want to put that as a decimal, then put it in. That works too. So you do that, and let's see what we get out. 2 divided by 30. Using inverse sine. We get 3 if we round to the nearest tenth. The measure of angle X, or angle of elevation, is about 3.8 degrees. And just the last part, it asks if it was in the desired range. So all it says, like, we want it to be less than 5, so it's not too steep that, you know, you're set and your props aren't sliding down the stage. So yes, it's in our desired range, we could say.